students, welcome to the cbse chemistry lecture series. In the last video we discussed the estimation of elements like carbon, hydrogen, oxygen, sulphur, halogens. Yes, these are the elements we discussed the estimation. Now today we are going to discuss about estimation of nitrogen. The estimation of nitrogen, there are two methods. One is a Geldahl method, another is a Dumas method. In this particular video we are going to discuss about Dumas method. So first of all we will discuss the principle. What is the principle behind this Dumas method? You can take an organic compound, suppose organic compound containing the elements like what? Carbon, hydrogen and nitrogen. This carbon hydrogen which will be converted to carbon dioxide and water vapor on treatment of what? CuO in the combustion tube. This carbon will be converted to carbon dioxide plus hydrogen will be converted to water vapor. These two are water, and if nitrogen is present, that will also comes out. Suppose if an organic compounds containing the elements like CX, HY and NZ. This is the things means how we have to find out how much amount of nitrogen is collected during this Dumas method. So in this case, as shown in the figure, there are important parts on that apparatus for the estimation of nitrogen by Dumas method. The first one is a combustion tube, which is a long tube, and that right hand side we have the graduated cylinder that is called Skiff's nitrometer, which is filled with, and then but one tube is that is what which is filled with a potassium hydroxide solutions, is fitted with a stand. So in this case, if the organic compound containing carbon and hydrogen, that will be converted to carbon dioxide and water vapor. So that combustion tube we are having a copper oxide. So that will be what? If the organic compound, the carbon hydrogen present, that will be converted when it is treated with a cupric oxide, that will be converted to carbon dioxide and water vapor. And that nitrogen gas, when these three gases are passed through the graduated tube, the graduated tube containing potassium hydroxide, that will absorb all the carbon dioxide and water vapor, and leaving only the nitrogen gas. That nitrogen gas will be collected in the another test tube or another tube. Okay, so in this case, how we can, I will explain this what apparatus first. There are three things are there. One is a carbon dioxide generator. There are three things. One is a carbon dioxide generator, another one is a combustion tube, and third part is a Skiff's nitrometer. So these are all discussed in this what clearly explained in this diagram as shown in the figures. The carbon dioxide generator is not given in the diagram, but Skiff's nitrometer as well as combustion tube is also there. Once we are getting collected that nitrogen gas in the reservoir, so we have to go for the calculations. Yes, the calculations. Yes, the mass of an organic compound. Mass of an organic compound, you can say W gram. And volume of nitrogen collected, volume of N2 collected, is nothing but V centimeter cube. And that atmospheric pressure, you can say, which is measured or read from the barometer instrument, P mm of mercury, capital P mm of mercury. And the aqueous tension is nothing, aqueous tension of the dry, you can say a small p mm, and pressure of the dry nitrogen gas, pressure of the dry N2 gas, which is equal to capital P minus small p, that is the pressure of the dry nitrogen gas. and room temperature is nothing but T degrees centigrade. Then we have to measure the values in two conditions. One is a experimental values, another one is a experimental values, another one is a STP values. What is the STP? Standard temperature and pressure. If capital P1 is nothing but what? Capital P minus small p, that is the pressure of the dry nitrogen gas, that is expressed in millimeter, and V1 is nothing but V centimeter cube, that is volume of the nitrogen gas collected here, and T1 is nothing but the temperature is given the centigrade, we have to convert it to Kelvin scale. So you have to add a 273 plus degree centigrade, that is a Kelvin scale expression. Similarly, we have to write for STP conditions. So P2 is nothing but what? 760 mm of mercury, that is a standard pressure, and the temperature, what is the temperature? T2 is equal to 273 Kelvin, and the V2 is nothing but question mark. So this one we are going to calculate by using the formula. What is the formula? P1 V1 by T1 is equal to P2 V2 by T2. This is the formula we are going to calculate the V2. So once what? Based on this you have to calculate it. V2 value is calculated. V2 is calculated. In the step 2 value, we are going to convert the volume of volume at STP, or you can say NTP. STP, standard temperature pressure or normal temperature pressure, into mass, calculated into mass. Okay. So according to the GMV, gram molecular volume, 22,400, either you can use a centimeter cube or ml, milliliter of N2 gas at STP, weighing equal to 28 gram of nitrogen. That is atomic mass of what? Nitrogen is 14, N2 means 28 grams. So we are going to calculate V2 centimeter cube of N2 gas at STP is nothing but 28 divided by 22,400 V2 grams. Okay. Then similarly we have to calculate for step 3. What is a step 3? It's a calculation of percentage of nitrogen. Calculation of percentage of nitrogen. That is a step 3. So in this step, percentage of nitrogen in the compound. Which is nothing but 28 divided by 22,400 centimeter cube into V2 by what? The mass of an organic compound W into 100. Percentage means 100. That is a formula for calculating the things. Okay. So more precisely you can say percentage of nitrogen is equal to 28 divided by 22,400 into volume of N2 at STP divided by mass of an organic compound into 100. So by using the Dumas method, we can finding the percentage of nitrogen by using this formula. Thank you students. If you have any doubts, please mention in the comment box. Thank you.